Hi, everybody. It is Friday. You are at home. I am here. But it gives me a great opportunity to recap the week that we just had. And boy, was it a week. Only 4 days. It's amazing how much we can accomplish in 4 days. And first of all, before I even get started, I want to continue to tell you how amazing you are and how thankful I am for how much you've worked, how hard you've worked in class, just showing up to class on time, ready to learn, the positive attitudes. I love it. And I hope we keep this momentum going. But like I said, in the 4 days, it is amazing how much we accomplished. First of all, the test that we took at the beginning of the week. Don't forget, if you are interested in retaking that test, you feel like you could do better, or you want to seal up those cracks or those holes in your learning that we talked about, which are so important to do right off early in the bat in the year before we continue to build upon that learning. If you want to retake that test, email me, let me know so we can set up a time. But also remember, you need to complete the means extremes module in Mathia before you can complete a retake. Okay, so as I said, we're going to continue to build, and we did already this week. And we started off on Wednesday, and we started a new unit where we are talking about this idea of proportional. We just got done with the unit testing on fractional rates and setting up a proportion to solve for these fractional rate problems. But now we're going to dive a little deeper into understanding what does this mean to be proportional, and more importantly, what does it look like? And that was really the question that we focused on this week. What does it look like in a table and a graph? And we start off the week, as we do every class period, just looking at what is our goal. And our main goal this week, remember, as we said, is looking at those tables and graphs and understanding what does it mean to be proportional and what does a proportional relationship look like in a table and graph. So we quickly then dove into our first scenario where we were looking at Bob and Jake, two guys that are building some bird feeders. And they said they only had enough material for 10 bird feeders. So between the two of them, they had to build 10. So we said, okay, if Bob builds 0, Jake would obviously have to do all of it. If Bob built 1, Jake would build 9. If Bob built 2, so we get this idea of, okay, they just have to total up to 10. And we quickly notice, oh, the more that Bob does, the less Jake does. And vice versa, the more that Jake does, the less Bob has to do. And so this idea of a negative relationship that we started to talk about that we'll talk more about. So we said, okay, again, going back to our main question of, is this proportional? We looked at, okay, are these ratios in this table showing a proportional relationship? So we made them into ratios. So for example, 1/9, does that equal 2/8? And again, the students in my class are brilliant. They immediately said, no, these are not proportional based on some things that we did in our last unit, like scaling, means, extremes. We could see that these are not proportional. So we said, nope, not proportional. Okay, so that's not proportional. Well, let's look at what does the graph look like? Even though we know that this is not proportional, let's look at the graph and see what is happening in the graph. So our next step was to graph this information. And in the graph, we found that we had a scenario that looked like this. Okay, the line was straight. Okay, or in other words, a word that we talked about this week, linear. Okay, we said the line is straight. It's a line. It's linear. But again, we determined in the table this is not proportional. But we still made some observations because we're trying to get this idea of what does it look like. So we said, okay, the line is straight, but here was the big one. We noticed it did not go through the origin. Many students said, they're used to seeing graphs that went through the origin. This one did not. Okay, so we kept moving on. Again, we're not drawing any conclusions yet because just like any science experiment, we need to perform a couple of experiments before we can and see some patterns before we can draw any conclusions. So then we went to our next scenario where we're looking at area, and we're looking at a rectangle that has a width and a length, but we want the area to be 12. So for example, if the width is 1, the length would be 12. If the width is 2, the length would be 6. If the width is 3, the length would be 4. And again, we filled in the table. Kids were very, very good about figuring out how this was working. And so immediately before we went to the graph, we asked ourselves again, is this showing a proportional relationship? So again, if I put these into ratios, does 1/12 equal 2/6? And again, because my students are brilliant, they said, no, those are not equal. Okay, up here, I would scale up by 2. And down here, I would have to actually scale down by 2. That doesn't work. I have to do the same thing the top bottom. So no, not proportional. So we wrote that into our notebooks, and then we went to the graph. And the graph in this case is actually kind of interesting. The graph in this one actually curves, does something like this. So again, we made some observations. This time, not only does it not go through the origin, we also said this one is not straight. It is not linear. Okay, and that word that we're going to continue to use throughout the year. It is not linear. So we saw another situation where it was not proportional. Finally, at the end of the week, we got to a scenario where we did have a proportional relationship. And we were looking at, not this scenario, let me go one more here. We were looking at a same situation with bamboo. Talked a little bit about bamboo. Okay, and in this case, we notice, hey, there is a constant rate. And we were introduced on Thursday to this word constant. Every day, this bamboo grows 60 centimeters. So after day 2, we got 120 centimeters, day 3, 180 centimeters, and again, we continued filling this table. And we noticed, oh, there's a pattern here. Every day, this is going up by 60, and over here, again, we're going up by once every day. And there is my constant. Okay, so we, again, led to the next question. Is this showing a proportional relationship? So let's check it out. Does 1/60th equal 2 over 120 or 3 over 180? And again, they all had to be proportional. And again, immediately, because my students are so bright, they said, yeah, those are all proportional. And we found it. Okay, we finally found that situation. Yes, they were proportional. So now let's take a look at the graph. This was our next step. What does it look like in the graph when we have a proportional relationship? And what we noticed is, number 1, we are going through the origin this time. And number 2, it is linear. It is a straight line. So we were able to draw a conclusion based on the 3 models that we saw. Hey, and again, we're just really making some observations. This is what we saw when it was proportional. We had a straight line and it went through the origin. Now, we did test that. We went into another scenario dealing with speed, somebody driving 60 miles per hour, and we saw the same scenario. It went through the origin, and it was linear. And this is where we concluded for the week. Okay, we got this idea of what it means to be proportional. And I shouldn't say we concluded, because the very last thing that we did is we were introduced to a vocabulary word, or vocabulary phrase, I should say, and the phrase was direct variation. We took some notes on this. And this is a concept that we're going to continue to investigate next week and really throughout the year. What does it mean when 2 quantities vary directly, or they have a direct variation? And the way I described it was, it's like a direct relationship. As this goes up, this thing also goes up by a certain amount. It's a constant. So like the bamboo, as we went every one day, the height continued to grow by 60 centimeters. That was our constant. And that word constant is going to be the next word next week that we're going to really, really focus on. And that is, again, related to this idea of a direct variation. So we're going to continue on. We again, just introduced this in the week. We're going to continue investigating this. All right, so hopefully for those that were in class, this puts a good recap and hopefully solidifies some things maybe that you were not quite understanding. Or if you weren't in class, hopefully this helps you get caught up. But I want you to have a good weekend. Get outside, enjoy this glorious weather that we're having this weekend, and I will see you Monday ready to learn. Have a good weekend, everybody.